Hello everybody. Today we interrupt the semiconductors chip design series and go back to calculus basic. The reason is I'm still getting occasionally the questions, the meaning of dy dx, and even the student in the college, they ask this kind of questions. Is this dy divided by dx? Is it? Okay, I'd like to clarify this, spending one more video here. The straight answer is yes. This is correct. What do you mean dy and dx? What's the quantity of dy and dx? And you can divide. And if in the derivative function delta x0 dy dx, what is related to this and this and this and this? This somehow a lot of students don't have a clear understanding. I think it's because this brain goes to the high school calculus math book. They never discuss these kind of things clearly. They just lay out whatever the formula and calculus, the how to do it, and a lot of students, even students in the college, still don't know if this is correct or not. Okay, here let's make it very clear. I'll give you answer first. Dy dx, this is division. Okay, but when you write dx fx, this is different. This is just notation. It's not division. It's not d divided by dx. Okay, this one is division. This is same meaning as derivative function. Okay, what is derivative function? When you have any function fx and x, if function is continuous, it has to be continuous, because I explain this later. Continuous function has derivative function associated with it. And what is derivative function? You take the slope here at this point x, okay, and this is the derivative function. Slope is derivative function. Okay, so I define dy dx here. We create a new coordinate at the point x we're looking at. Okay, and this coordinate name is dx, coordinate name is dy. Okay, so dy is, since this is a slope, dx, right? The same as y equals m d mx. Right? No misunderstanding. Okay. The m d mx plus b. This is the linear equation, and since this derivative function goes through the origin, this is 0. This mx, m is slope, and x is dx, and y is dy. Okay, so you in this coordinate, new coordinate you create a coordinate at every different x value. If x move to here, then you create new coordinate, and that's gonna be dy and dx coordinate. Okay, so dy equals f prime, which is a derivative function of fx, which is the slope. Slope is m, right? The y equal mx plus b. You learn that in the algebra, right? This is actually the equation. So if dx is 2 and the slope at x is 3, then dy is 6. Okay, now let's go back. In the derivative function definition, you blame the teacher, right? You told me delta x go to 0. So this is a very small value, and this is very small value. And if it's equal, dy has to be very small value. Okay, here's a big misunderstanding. Derivative definition of derivative function is said the ratio of this small value is equal to the ratio of dy dx. Dy dx is not small at all. Dy dx is any value you can take. Okay, this is a new coordinate and dy dx. So dx dy is a new variable, and you define this new function, dy function. Dy function is this is slope times dx. That's what it is. So what it's saying here, you have to be very careful. It's equal when delta x goes to 0, and that means delta x and delta y become very small, but they are not equal to dy dx. Dy divided by dx, this ratio is equal to dy dx. And that makes sense, right? Because if you take a delta x here and take a delta y and take the ratio and make a delta x small, then it's get close to this slope line, which has only one contact to this function. Okay, so that's the that's ratio becomes same as this ratio. So ratio is equal. Nobody say dy the delta y become dy, delta x become dx. Nobody said this. The ratio is equal. Okay, and that's a big misunderstanding most of the student has when they learn the calculus. For example, you take a 3D case, right, and has some curves here. Okay, now you take any point. This is x, y, z, and this point is x, y, and this is z, right? Okay, and here the slope function, we can define two slope function parallel to x. Okay, parallel to x. This one, if this function is z equals fxy, multivariable, right? Then dz dx. And why we write d this way? Because this is the derivative function when y is constant. Okay, so we define partial derivative. We call this partial derivative when y is constant. Okay, and when x is constant, Okay, then we have another dz and dx, or dy, I'm sorry, right? Write it very clearly. When x is constant, since it's multivariable, we have two different partial derivative function. Okay, this partial derivative function define this line contacting this parallel to x, because y value is same on this line and x value is same on this line. So you make a new 3D 3D coordinate at this xy point. So what's happened? We can define new variable dz. And what is dz? Dz is going to be dx and dy. You take this quantity, dz is going to be dz dx dx. This is slope, plus dz dy dy. So this equation is like that's plane defined by these two functions. This is a linear function. Define the one plane which is touching to this this function, right? And amount of dz depend on dx multiplied by this slope and dy multiplied by the slope. So it's like, you know, the plane is like m1 x plus m2 y. You can write this way. This is a linear equation, right? So it's a plane, and not like this curved function. This is a curved function. Okay, so you can define at the xy location, okay, the new coordinate and amount of dz. This is a new variable, depend on variable dx and dy. So this is the actually derivative function of multivariable. Okay, so you need a slope along the x and you need a slope along the y. Those are called partial derivative. Partial derivative. Okay, so this is a partial derivative, tells you how much it's going to change when you move by amount of dx, and this tells you how much is going to change the amount of height change when you move amount of dy, and you add up, is going to be total change of the height. Okay, so this is the partial, this is a derivative function of multivariable x and y. Z depends on x and y. So write correctly. So this x dx dy dz is not small amount at all. It's a new variable you defined by new coordinate at the point you are looking at. Okay, so if you run the integral, it's the same thing. dy equals some kind of gx dx, right? And integral is dy y integral. This is the operator they call operator. This cancel out. In order to cancel out, you have to take a derivative. Integral of this function. That's why you have a dx here, and this cancel out. This is going to be y. So when you have function gx, derivative function, the dy equal gx dx, then you take an integral, you get the original function by taking integral of this. So you always have dx in the integral. Okay? Now, again, let me emphasize, when you write this way, this one is not the divided by dx. This is just the symbol, same as prime x, and this prime is much easier than this way. Okay? So this is not a division. Okay? But when you write this way, this is d fx divided by dx. Okay? I hope it's clarify what dy dx means. And derivative function has to be continuous, and definition of continuous function, there is if you go deeper into calculus study, there is a epsilon delta logic. The epsilon deltas define what the continuous means. Okay, and real number is continuous, but the derivative is defined within continuous, and also one more condition is smooth function. What's a smooth function? Smooth means it's not like this function. There is a kink here. Okay, if there is a kink, as you see, this slope, you can define two different slope. So slope function has two value here. Okay, so there are two conditions. Derivative function exists within a domain. Domain is a range, say x, right, of continuous and smooth. Continuous means if the real number going continuously, then that's continuous, and there's no kink like this. Then smooth, then derivative function exists. Derivatives function of the original function. This is the original function, and you can have derivative function. And those are another layer of the calculus math. You can delve into this deeper side of the theory. For example, what kind of number system is continuous? Okay, integer is not continuous, right? How about you add any p over q. What is this? The rational number. And rational number is not continuous. Okay, the real number is real become continuous, and continuous definition come from epsilon delta logic, which required infinite concept, and the entire calculus is based on this new concept of the number, infinite Well, I just give you a little bit flavor. What is the number next to number 2 in the number line? What is the number next to 2? Okay, it's not 2.00001. It can be smaller. How small it can go? Infinitely smaller. It's called infinitesimally small number. Okay, so 2 plus infinitesimally small number, some number, is next to 2. And this we cannot define by writing, because it's a continuous number. Get it? Well, that's a fun part of the calculus. So you can read the book about this part. So talk about what is continuity. And as long as it's continuous and smooth, you can have a derivative function. And mathematicians try to define the meaning of continuous and smooth. How do you define smooth mathematically, right? It's easy to say, yeah, it's continuous. What do you mean continuous, right? The rational number is not continuous. I tell you why. Suppose 0 and 1 and 2 and 3. And if this is a rational number line, and show me where square root 2 is. Okay, square root of 2 is be somewhere around here, but it's larger than rational number next to it and smaller than rational number to it. Means rational number has gap between. This number is a proof there is a gap. It's not continuous. Okay, so the real number is continuous because square root of 2 goes in, pi goes in, if e, Euler's number goes in, any number goes in, but the number you didn't learn in high school is infinitesimally small number. What is infinitesimally small number? That's a real number, but what is it? It's not irrational number. It's not irrational number. Is that a rational number? No, it's not a rational number. So something you didn't learn, a little bit I disclose, is you have a rational number and irrational number make up real number. It's not true. There is another kind of number here you have to add on. Infinitesimally small number. Infinitesimal number. And what kind of number? It's like infinite is one of them. Infinite is not a rational number or irrational number. Well, when somebody asks, kids ask, what is the largest number in this world? Then one kid said, well, 10 billion billion. Another says, oh, trillion trillion, right? Then one smart kid said, oh, number you say plus 1. Okay. Number you say plus 1. What is this number? Whatever the number you can think of plus 1. What is this number? This is not a rational number. This is not irrational number. This belongs to here. And calculus need this type of number. And they don't talk about this number. They just teach calculus without teaching this new number. Okay? And that's the source of all confusion when you run the calculus. So if you depend on high school calculus textbook, you never get it. You have to read and research by yourself. That's the way I understood the calculus finally, because this type of number is not real number, it's not a rational number, it's not irrational number, it's not any number you learned so far, because any number plus 1. What's any number plus 1? What kind of number is that? It's infinity, right? Any number plus 2, also infinity. What are those numbers? That's what it is. I hope you feel curious. If you have a curiosity on calculus, you read more, you have complete understanding of calculus. Okay, that's it for today. If you like this video, please click subscribe, and we go back to semiconductor chip design in the next video.